Hello everyone and welcome to Edusurg Clinics where we discuss some key topics related to common medical and surgical practice. Statistics was a very commonly asked question and a request from a lot of our viewers. So we have started this series on statistics made easy. Today we are going to cover the entire topic of sampling methods, what is sampling, the concept behind it, as well as all the various methods that are used for sampling. So let us begin. So in this series, in the previous videos, we have already discussed based on the DCOVA framework, that is the type of variable, the type of measurement scale, and the type of data. We have seen nominal, ordinal, interval, and ratio in the previous video. So today we are going to focus on sample and sampling. Now, what is the concept of sample and population? We will see with the help of an example. And this is the example that we are going to use throughout this entire video. So suppose you are running a hospital and you are assessing whether your hospital needs electronic health records. Okay. So we see that a lot of decisions in hospitals are made without taking employees' opinions into view. Well, we are not running that kind of a hospital here. The hospital is interested in knowing the employees' viewpoints. However, this hospital has around 2000 employees, and asking all of them, you are never going to get a consensus, right? So this is a problem. Now, the possibility of data collection can be that you ask all the employees, or you select a sample by sampling the population. Okay. So here the population is finite. Now, these terms should be clear to you by now. Otherwise, look at the previous videos. Population in our case here will be all the employees of the hospital. I have said that there are 2000 employees, so this is a finite population. And if the right hand side of your screen is showing all the employees, then we can select a representative and random sample, okay, by sampling methods. Okay, so this is the entire concept. This is very important to understand that the population, when cannot be studied as a whole, what we do is we use the various sampling methods that are described in this video to find a sample. Okay, the sample should be representative and it should be random, as we have already seen previously, to avoid biases. Okay, once you have selected the sample, you can analyze the sample and come to some conclusions. Okay. Now, answers of analysis of sample are known as statistics. Okay. So, answers of analysis from sample, mean of sample, median of sample, these are all statistics. Okay. And then what we do is based on these statistic values, suppose the mean is 20, then we use this statistic 20 to estimate the population mean. Okay. So what this means is that suppose we have selected 200 employees after 2000. Okay. If 100 of them say that yes, electronic records are important, then that should be an estimate in a way that around 1000 out of 2000 will say that electronic records are important. Okay. This is what is meant by use of statistical value to estimate the parameter, right? So what we are doing here is we collect a sample, we analyze the sample, we do our various techniques like mean, median, mode, standard deviation, etc. on the sample. Answers of the analysis are known as statistic. Statistics are used to estimate parameters. And the last step, which we are going to study in future, is hypothesis testing. Okay. What this test basically is how good is the estimation. That is how accurate is the statistic as a measure of the parameter. Okay. And this is basically the inferential statistics. So I hope you are clear with the concept. All these terms we are going to discuss in detail in future. So sample, as I have already said, we will discuss sample size determination in future sessions. Now we are coming into sampling. So sampling, as we have already seen, is choosing and selecting an adequate sample from a population. Okay. There are two types of sampling, non-probability sampling and probability sampling. We know probability is a chance event or a chance that a particular person will be selected, right? Probability sampling is random sampling, but it takes longer time. However, probability sampling is more objective and it is more representative. So, random, representative, and objective, these three words are important in probability sampling. When we are looking at non-probability sampling, it is based more on convenience, it is easy and fast, and it is subjective. We will see both these techniques in detail in upcoming slides. Like I said, probability sampling is very routinely used. Probability sampling again has two types, that is sampling with replacement and sampling without replacement. What that means is, suppose we are selecting cards from a deck of cards. As we all know, there are 52 cards in a deck. If suppose we remove the ace of clubs, now if we put this card back before selecting another card, that is sampling with replacement. What that means is that the ace of clubs can be selected multiple times, right? If we don't put the card back, it is sampling without replacement. Statistics, to avoid confusion, it is very clear that we use sampling without replacement in probability sampling. Okay. So now going into probability sampling methods, the first is simple random sampling. Each word is important. It's simple. It is random because it's probability sampling. The problem is now the same, 2000 employees, and we have to select 200. Now this sample we are going to select by the technique which is known as simple random sampling without replacement. Okay. So what are the steps here? It's very simple. Give each of an employee the number. Okay. Then you can use table of random numbers or a computer software which is now available to generate 200 random numbers. And the numbers that you have selected, compare them to the numbers that you have given to the employees and select your 200 employees based on the selected random numbers. So this is an example of the table of random numbers. This table is available online as well as in a lot of statistics books. What you can do is you can select a random number by pointing a number with closed eyes or any other method that you want to use. Suppose I have selected this 46063. Now I can go in sequence vertically downwards or horizontally, or I can go in both directions. What we typically do is we use the first two or the last two digits while going down. So the employees that you are going to select can be 63, 68, 49, 80, 83, and so on. If you are going vertically down, it can be 63, 65, 78, 41, 62. If you are losing the last two numbers to reach 200 samples. Okay. So once you have made a list of these numbers from the table of random numbers, then you compare your employee numbers with the numbers that you have selected and select those employees, right? I hope that is clear. Again, to give you an example, suppose I select the first left hand corner digit and which is 13962, right? The first topmost number is 13962. Now I can decide whether I want to use the first two or the last two. Say we are using the first two and going vertically down. So your selected random numbers will be 13, 43, 61, 83, 36, 19, 82, 5, 6, 84, and so on till you select 200 numbers. So this is simple random sampling. Now going to the next technique, which is systematic random sampling. Again, our problem is the same. Technique is systematic random sampling without replacement. Again, we have to give each of the employees a number. Now, by using the table of random numbers or a computer software or a toss of a die, you select a random X value as your starting point. Okay. Then you select another Y value in similar fashion as an addition factor. Now here we know that we have to select 200 employees after 2000. So we know that if the Y is more than 10, then you are going to have a problem at some point, right? Because you are going to select your numbers as X, X plus Y, X plus 2Y, X plus 3Y, and so on. Okay. So what A simpler method suggested is that what you do is you divide 200 by 10, that is 20, right? And your y should be any number between 0 and 20. Now, this is not an established or a technique that has to be used. This is something that we use. Okay, but systematic random sampling can be done by using table of random numbers as well. You select a random x, you select a random y, and then you continue doing your x plus y, x plus 2y up to x plus 199y. Now going into stratified sampling, right? So there is again the same question. Technique is stratified random sampling without replacement. What is meant by stratified sampling? You divide the data into strata. Now, strata are not naturally occurring groups. Okay, naturally occurring groups are clusters, and that is why it is known as cluster sampling. Okay, strata are something that you define. Okay, so for example, here we have given number of years of employment in hospital, and you divide it as say less than 3 to 6 years, more than 6 years, right? So there are three strata now. You can do random and systematic sampling in each strata. Suppose you have 300 employees less than 3 years, 700 employees in between 3 and 6 years, and 1000 employees more than 6 years. You can do random or systematic sampling in each strata. There are two ways to do it. One is that you ignore the number of people in each strata and you do a one third, one third, one third sampling in each of the three, right? If you have five strata, you do one fifth in each of the five. So here you are not considering the proportions of people in each strata, right? What I am trying to say is you will never have strata which have equal population, right? But you can do sampling even without considering the percentage of person in each strata, or you do stratified sampling in proportion. What that means is if the first strata caters to only 20% of the population, for in this case, suppose the first strata has only 400 employees, then you will do only 20% sampling in that strata. Okay. The second strata is 35% employees, so you will do 35% sampling. And the third strata has 45% population, so 45% of your sample will be collected from the third strata. So this is known as stratified sampling in proportion. Again, this is random, or you can do a systematic random sampling as we have seen previously. So both the previous methods are used within strata, but dividing the strata and whether to use it in proportion or not is the main question. Now, like I said, for using the same problem, here we are using naturally occurring groups which are known as clusters. So for example, we take that suppose the hospital has 20 floors and we divide the population into floor, ground floor, first floor, second floor, third floor, right? These are naturally occurring divisions. You are not putting one person in second floor, one person in first floor. They are wherever they are. So this is a naturally occurring group or a cluster. And then what you do is you select clusters. Okay. Now here we know that suppose there are 20 clusters. So each cluster will roughly have around 100 employees and you want to select only 200 employees. So what you will do is you will use random or systematic sampling to select two clusters, right? Because you need 200 employees. This is known as single stage cluster sampling. That is, you have selected two clusters which satisfy your criteria. Okay, there is also something known as multi-stage cluster sampling. What does that mean? What that means is that after you have selected your clusters, say you selected four clusters, you do random or systematic sampling within the cluster. Okay, that is known as two-stage sampling. So in single stage sampling, we just select the cluster, right? In two-stage sampling, we select the cluster and then we do random or systematic sampling within the cluster. So you are not selecting all the employees of one cluster, but you are doing random or systematic sampling of each cluster, right? That is multi-stage cluster sampling. There is also a technique where once you have selected your four clusters, you do a systematic sampling to identify a subcluster. Okay. And this is known as a three or a multi-stage sampling, because then you can do random or systematic sampling within the subcluster. Okay. This is a bit advanced. What you need to know is that clusters are naturally defined groups. Multi-stage sampling is asked sometimes in exams. That's why I'm trying to discuss. Suppose you want to do a two-stage sampling. What that means is that after you have identified the clusters by random or systematic sampling, you identify part of cluster again by random and systematic sampling. Okay, that is known as two-stage. Coming to three stage, what you do is once you have got clusters, say you selected these four clusters, okay, then you do random and systematic sampling to identify a subcluster, okay. Suppose in this example, in 20 floors, we say that we will take only the left wing, okay. So what you are doing is in this floor, four clusters, you will select the subcluster, that is the left wing, right? And then you do random and systematic sampling in the subcluster. That is why it is known as a three-stage or a multi-stage sampling. Go through these two slides two, three times, and you will understand what I am trying to say. Now going to non-probability sampling, this is a very simple concept. Like I said, it's a convenience-based sampling. So the first type is convenience sampling. What that means is you just select the first 200 people that you meet. Very convenient, right? Another is known as judgment sampling. That is, since we want electronic records, we select people like computer experts or physicians who are going to need it, or nurses who are going to need these records, or experts who already use these records. Okay, so that is known as judgment sampling. Another type of non-probability sampling is known as snowball effect. What that means is that I would select a person, then that person would select the next person. The next person will then select the next to next person, right? So that is known as a snowball effect. So these are some of the types of non-probability sampling, not routinely used because this is not representative, not random, and has a high probability of bias, right? So after this, a very specific type of non-probability sampling that I would like to discuss is also known as quota sampling. Okay. Specifically, the problem here is that you need to select 200 employees as a sample, but it should have 100 women. Okay. This is known as quota. Okay. So when you have been given a fixed quota, you can select the most convenient 100 or judgment on 100, but with the knowledge that you need 100 women and 100 men. Okay, this is known as controlled quota sampling. Okay, that you have 20 clusters same as before. You select the most convenient clusters. Okay, if research department is on 10th floor, you select the 9th and 10th floor, right? So that is convenience based quota sampling, also known as uncontrolled quota sampling. Okay, so when you have been given a specific quota, that male and female 100, that is known as controlled quota sampling. When there is no such quota, but you have clusters that are available, but still you use convenience sampling, that is known as uncontrolled quota sampling. Now, I know there is a lot of confusion between these three types, that is stratified sampling, cluster sampling, and quota sampling. So in this single slide, you can see the differences between the three so that you don't get confused. We have already seen that quota sampling is a non-random sampling where you can have controlled or uncontrolled quota selection, but this is not a routinely used method as it is a non-probability sampling. In probability sampling, we have already seen cluster and stratified sampling. In stratified sampling, the strata need to be defined or created, such as top, middle, and lower level. Whereas in cluster sampling, the clusters are naturally occurring groups. Then you can do sample within each strata, whereas in cluster sampling, you can select the entire cluster or you can select clusters within the sample. Thus, to summarize sampling methods, there can be probability sampling and non-probability sampling, or random sampling and non-random sampling. In probability sampling, you have simple random sampling, which is done using the table of random numbers or the computerized software. Then you have the systematic sampling. Then you have the cluster, which can be 1, 2, 3, or multi-stage cluster sampling. And then you have the stratified sampling, which can be random or systemic stratified sampling with or without the concept of proportion, right? Going to non-probability sampling, it can be convenience sampling, judgment sampling, snowball effect, and quota sampling. So all these techniques are discussed in this video. Go through it 1 or 2 times, and I'm sure this will solve all your queries regarding sampling methods.